Okay, now we're going to summarize the simplex method. First step, use slack variables, convert the linear programming problem to a system of linear equations. Second step, set up the initial tableau, include objective function as the bottom row. Step 3, select the pivot column. The rule for selecting a pivot column is this. Look at all the numbers in the bottom row, excluding the answer column. From these, choose the negative number with the largest magnitude. Its column is the pivot column. If there's two candidates, choose either one. Normally, though, try to go to the one to the left. If all the numbers in the bottom row are 0 or positive, then you're done, and the basic solution is the optimal solution. But you know 9 times out of 10, that's not going to be true. Step 4, select the pivot in the pivot column. The pivot must always be a positive number. This rules out division by zeros and negative numbers. For each positive entry B in the pivot column, compute the ratio A divided by B, where A is the number in the rightmost column in that row. Remember our little ratios that we get. Of these ratios, choose the smallest one. Corresponding number B is the pivot, and that's where our arrow comes in from the side. Use the pivot to clear the pivot column in the normal manner. This gives the next tableau. Repeat steps 3 through 5 until there are no more negative numbers in the bottom row. The solution for the linear programming problem is then the basic solution associated with the final tableau. So, of course, I've got an example, and I need you to go from start to finish. So, use the simplex method to solve the following linear programming problem. So, first thing, got to remember what you have to do. These have got to be put into a matrix, and normally the first thing we do is change these. So go and change them. Get them ready to go into the matrix. Pause me, so you can go ahead and write them down and see if you end up with the following. Put it in this order, so that'll be the order that it'll go into the matrix. So the next thing, label your column headings. Do that so you can get everybody in the correct position. So go ahead and put them in the matrix. And you should have that. So, first thing, arrow coming up with the most negative. So our choice would be this one. Go do the necessary quotients. So 118 divided by 1, 220 divided by 1. You choose the smallest, so the arrow should be coming in at the very top. So where the two arrows meet, that is your pivot. So let me go get myself a little circle so I can have a pivot. Let me center it. Okay. And write out your steps. Make this a Gauss-Jordan column. Now before you go do that, look at this solution. X sub 1 is 0, X sub 2 is 0, X sub 3 is 0. S sub 1 is 118, S sub 2 is 220, Z is equal to 0. Guys, that right there would correspond to the corner at the origin, which our maximization problems, that's usually one of the corners that we have. So go ahead and write out your steps and see if you have the following. So pause me. Since I already have a 1 there, I just need to use that to get rid of these, and hopefully you've got that. Now apply that to this matrix and see if you've got the following. Since the bottom row is greater than or equal to 0, this is it. We are done with this problem. We just have to answer it. X sub 1 would be 118, X sub 2 and X sub 3 would be 0, S sub 1 would be 0, S sub 2 would equal 102, Z would equal 944. That'd be my maximum value. So that would be my solution. And that's it for this particular video. You need to do some of these problems because you're going to have maybe a couple that you've got to go from the start to finish with. Okay? Thank you.